In this video, we'll be talking about two important theorems that have to do with circles. The first theorem has to do with tangents to circles, and the second has to do with chords. So the first theorem, like I said, has to do with lines that are tangent to a circle. So just remember what that means. Remember, a tangent line is a line that touches a circle at exactly one place. A tangent segment is like a portion of a tangent line. So it's a segment, but it only touches the circle at one spot. Okay. So just a reminder of what tangent is. So here's the theorem. If you have two tangent segments to a circle, and they have a common endpoint outside the circle, then the two segments are congruent. So if you look down in this picture, we have these two tangent segments RS and TS. They're both tangent to the circle, and they have this common endpoint S outside of the circle. That means that those two segments are going to be congruent. And remember these little tick marks that we have right here? Those mean that the segments are congruent. We can also write this in symbols. We can say segment RS is congruent to segment TS. So let's go ahead and use this theorem. In these next examples, we're going to assume that DE and DF are both tangent to the circle C, and we're going to find the value of x. So if we're assuming that DE and DF are tangent, and they both have a common endpoint of D, that must mean that x plus 10 and 17 are equal to each other, because those are the lengths of both of those segments. So I can set up an equation, x plus 10 equals 17. Then I'm just solving for x. So I have x is equal to 7, and that's my answer. I can do a similar thing in the next problem. So again, I'm assuming that DE and DF are both tangent segments, and they have this common endpoint D. So that means that these two segments are congruent to each other. And congruent means they're the exact same length, which means that 6x minus 2 has to equal 4. So I'm going to go ahead and solve for x. I'm going to add 2 to both sides to get rid of that minus 2. Then I'm going to divide 6 on both sides to get rid of the 6 in front of the x. 6 divided by 6 is 1, so my x is equal to 1. So pretty straightforward theorem. Lets us find the length of some segments. Let's look at our second theorem. This theorem has to do with chords. So remember, a chord is just any segment where the endpoints are inside the circle, are on the circle. So there's nothing necessarily like special about chords as long as both the endpoints lie on the circle. So here's our theorem. If two chords cross in a circle, the two pieces of one chord multiplied together equal the two pieces of the other chord multiplied together. So a little wordy, but let's just go ahead and talk about that. So first important thing is that we have two chords in the same circle and they're crossing each other. And we can see that here with chords AC and BD. Then you'll see that where they cross, they kind of break the chord into two pieces. So I'm just going to label these pieces as actually let's choose letters that we don't already have, as X, Y, Z, and N, I guess. Okay, so what this theorem says is that if I multiply the two pieces of one chord together, so like X times Z, those are the two pieces of the first chord, that's going to equal the two pieces of the other chord multiplied together, so Y times N. So let's go ahead and talk about how we would use this theorem to solve for some missing lengths. So in example A down here, notice that I have two chords, chord J, G, and chord F, H, and they cross within the circle. And I know the lengths of every piece of the chords except for this X value. So I've got to figure out what that is. So I am going to use the theorem we just barely talked about. We know that if I multiply X times 4, so 4X, that's got to equal 5 times 8, which is 40. I better write that out just in case we're still learning this theorem. 5 times 8. So the two chunks of one chord multiplied together equals the two chunks of the other chord. So I have 4x is equal to 40. Divide both sides by 4. And I get x is equal to 10. We can do the same thing in the next one. So we have two chords that cross in the same circle, which means that the 8 times the x is going to equal the 6 times the 16. I don't know what 6 times 16 is, so let me figure that out with my calculator. 6 times 16 is 96. So 8x is equal to 96. Divide both sides by 8, and I get 12. So x is equal to 12. All right, next one has bigger numbers, but it's the same process. Go ahead and try this one on your own and then come back and check it. All right, the value for x in example C is 8.5. So just a caution as you're using this theorem, make sure that you are matching up the pieces of the same chord together. So like the x and the 24 are the ones that are multiplied together, and the 12 and the 17.